Hi everyone, I hope I find you well. In this video, we are dealing with the bearings and distances. So we have a question here, but it's slightly different from the previous question on bearings and distances. So let me read the question to you. 3 ports A, B, and C are situated so that AB equals 60 kilometers and AC equals 100 kilometers. The bearing of B from A is 060 degrees and the bearing of C from A is 290 degrees. Calculate the distance BC, the bearing of B from C. Okay, so we are going to use this diagram to answer the questions. So remember, 3-figure bearings or true bearings are measured from the north and then you turn clockwise. Okay, north, then turn clockwise. So the bearing of B from A is this angle which is between the north arrow and the line which goes to B, which is AB. And the bearing of C from A is this angle which starts from the north arrow and then turn till we touch the line AC, which is 290 degrees. So according to the positions of B and C and A, the distance BC gives us the third side of the triangle. So we have got a triangle here, and I'm going to use the cosine rule to find the length of the distance BC. So for me to use the cosine rule, I must know the whole angle CAB. But for now, I only know the size of this angle 60 degrees, which is between north arrow and AB. So I must know the size of this angle, which is between the north arrow and AC, for me to have the whole angle CAB and then proceed to use the cosine rule. Remember, the cosine rule is used when you have the lengths of two sides, e.g. 60 and 100, and an angle in between them, which is CAB in this case, so that I can find the third side, BC. Okay, so for me to know this angle, remember at A, angles at a point A, they add up to 360 degrees. But I know that from north arrow to this line, AC is 290. So for me to get this angle, I simply say 360 degrees minus 290 degrees, and then I get 70 degrees. So the side of this angle here is 70 degrees. Okay, so now the whole angle CAB is given by 60 degrees plus 70 degrees, which is called 130 degrees. So this whole angle CAB is now 130 degrees. So now I'm going to use the cosine rule to find BC. Okay, so BC raised to the power 2 equals to AC raised to the power 2, which is 100 squared, plus AB raised to the power 2, which is 60 squared, minus 2 multiplied by AC, which is 100, multiplied by 60, which is multiplied by 60, which is the length of AB, multiplied by cos 130. Okay. If I simplify 100 squared plus 60 squared, I get 13,600. The cosine of 130 degrees is negative 0.6428. So here I've got another negative. So the negative which comes from the cosine of 130 degrees and this one gives us this positive. So I have 13,600 after adding the squares of these two plus 12,000 multiplied by 0.6428. Finally, when you add this, you get 21,310. to 4 significant figures. So for me to get BC, I find the square root of BC squared and the square root of 21310. So finally, my BC becomes 146 kilometers. Okay, so let's move on to part B of the question. Part B of the question. In part B, I want to find the bearing of B from C. So first of all, I need to find the size of this angle C at C here. So I'm going to use the sine rule, which says the sine of this angle C over the opposite side 60 equals to the sine of this angle 130 over the opposite side 146. So sine C equals 60 multiplied by sine 130 over 146. That's after cross multiplying and simplifying. So sine C equals 0.3148127. And finally, the angle C. If you go to your calculator and then you press the second function button or the inverse button and then enter 0.3148127, you get angle C as 18.35 degrees. So this angle here is 18.35 degrees. Okay, so let's proceed. So remember, on part B, we want to find the bearing of B from C. So we put our north arrow at C there, because we want to measure from C. C is our reference point, so we put our north arrow at C. So the bearing of B from C is this angle here, which is between the north arrow and the line BC. This one, that's the bearing of B from C. Remember, 3-figure bearings always measure from north clockwise. So it's from north arrow up to the line, moving clockwise up to the line BC. Now, we now know that this angle inside the triangle is at C is 18.35 degrees. AC is a straight line, and the straight line adds up to 180 degrees. The angle here between the north arrow and AC produced is 70 degrees because it is a corresponding angle. It is equal to this 70 degrees here. And NCA equals to 110 degrees. If we remove 70 degrees from 180, remember this is a straight line, we get 110. So NCA is 110 degrees. So for me to get the bearing of B from C, which is this angle here, I simply say 110 degrees minus 18.35. So 110 degrees is NCA. 110 degrees minus 18.35, I get 91.65 degrees. So as a 3-figure bearing, the bearing of B from C is 091.7 degrees. Remember, in true bearings or 3-figure bearings, any size of any angle which is below 100 degrees, we put a 0 before putting the digits. So as I've done here, so it's 091.7 degrees. That's the bearing of B from C. Thank you for watching. Meet you in the next videos.